So now that we know that DNA makes up genes and genes make up chromosomes, and these genes and chromosomes are passed down from generation to generation, from parents to offspring, we could take a look at how these genes make you look the way you do. Okay? Now, genes, remember, code for specific traits. Your eye color, your hair color, whether you're born with a tail or not, okay, if you're a dog, whether you're going to have big ears or little ears if you're a bunny rabbit, okay? But now these genes come in different types, okay? You can have something called a dominant gene, which likes to show itself. Dominant genes always like to show themselves. They like to be out in front. They like to get out on stage. They want to show themselves. And that's the physical appearance that you're going to portray if you inherit a dominant gene from one of your parents. We also have these things called recessive genes. Recessive genes are there, but they're hidden. They don't like to come out and show themselves, especially if there's a dominant gene available to show itself instead. I like considering a recessive gene kind of like stage crew of a play. The play can't happen. The performance can't happen without the stage crew working behind the scenes. And that's kind of what a recessive gene is. Recessive gene is there, but it likes to stay hidden. Now, when we talk about these dominant and recessive genes, okay, we portray them with capital or lowercase letters. You know it's a dominant gene if we use a capital letter. For instance, brown hair is dominant over blonde hair. So we would show brown hair using the letter capital B. Okay, that means you're going to show brown hair if you get that gene inherited from a parent. Blonde hair is always recessive to brown hair. So we portray this with a lowercase b, knowing that you have the gene for blonde hair. You can pass that gene on to future offspring for blonde hair, but you yourself may not actually have blonde hair because you have the dominant gene that shows itself instead. The recessive gene is there, it's just hidden away. Okay, so we have two types of genes: dominant genes that like to show their trait, and recessive genes that kind of like to hide in the background. Now, you always get one gene from mom, one gene from dad. This is what's known as your genotype. Your genotype is the letter combination of what you've inherited from your parents. Genotype, the genetic makeup. The two-letter G's go together. Genotype, genetic makeup. Okay, it's our code. It's our genetic code for what we're going to show. Now, you can have a couple different combinations since you're getting one gene from mom and one gene from dad. If you inherit both the same gene, whether it's capital B, remember capital B's are dominant genes for brown hair, or lowercase b, those are recessive genes, they like to be hidden from blonde hair. But if you inherit both the same type of gene from mom and dad, that's what's known as a homozygous gene pair. Okay, homozygous gene pair. They are the same letter. Homozygous means they have the same letter. So you can see here, Andy Roddick, famous tennis player, capital B. That means mom and dad both gave Andy the dominant trait for brown hair. So he was born with brown hair. Maria Sharapova over here, another famous tennis player, has blonde hair. That means her mom and her dad both gave her recessive genes, little b. That's your genotypes. Big B, little b are your genotypes. So since she has two recessive genes, and they like to be hidden, but there's nowhere to hide. So that's why if you have two recessive genes that are given to you, you are still going to show that recessive trait. So that's two combinations. The third combination happens when you get one of each. This is what's known as a heterozygous gene pair. So you have one dominant trait and you have one recessive trait. Now, what are you going to look like? That's the whole point of this. You're going to look like you have the dominant gene. Because remember, that recessive gene likes to hide. It doesn't like to show itself. It's there. It can be passed down to your offspring, but you're going to show the dominant trait if the dominant trait is there. So we call this a heterozygous gene pair. Okay, heterozygous, 2 different letters. Homozygous, 2 of the same letters. Okay, and they code for what trait you are going to show. So let's review. Here we go. Now, a phenotype is what the physical appearance of that gene pair looks like. Phenotype, physical appearance. The 2 PHs go together. Okay, it's not just good enough to know what your genotype is. Hey, that's some nice dominant B gene pair genotype you have. No, that doesn't make any sense. That's some nice brown hair you have. Hey, that's a really nice homozygous recessive gene pair you have there for your blonde hair. No, that's silly. You've got nice blonde hair. So what we're going to do here is we're just going to take a look at what the gene pair would look like, what would we call the genotype, and what would the phenotype be, the physical appearance or the words we use in everyday life. So here we go. Our first gene pair, capital B for brown hair. What would we call this genotype? Bones, since they're both capital letters, they're both dominant genes, what would we call this genotype? Homozygous or heterozygous? No, the ones that are the same. Good. Homozygous. A homozygous gene pair, capital B, because both are dominant, okay, we said they're dominant, capital letters, this person will have brown hair. Now, what if both are recessive? Both are recessive. Do you remember capital or lowercase letters, Bones? Lowercase, very good. So little b. This is homozygous as well because they're both recessive and they're both the same. So what color hair are you going to have? If you had hair, Bones, you're right. You would have blonde hair. Now, what if one is dominant and one is recessive? What would it look like? What would the gene pair look like? Good. One of each letter. Capital B, lowercase b. The genotype now is no longer homozygous. We call it heterozygous. Very good. Now, even if we are heterozygous, we don't say that's some nice heterozygous hair. What do we say? If there's one dominant and one recessive, which one's going to show itself? Bones? The dominant one. Very good. So your phenotype, or what you actually would look like, is you would have brown hair because you have the dominant trait for brown hair being expressed. Okay? So we have dominant genes and recessive genes. The gene pair is your genotype. If you have 2 of the same, you're homozygous. If you have 2 different, you're heterozygous. And your phenotype is your physical appearance. Okay? Now we're going to take these in the future and we're going to start combining them together to see if you were to have offspring, what would those offspring look like, and figure out why you look the way you do.